Okay, good evening, everybody. Can you hear me? We mic'd up? Excellent. So I'm going to be talking to you about migrating to the cloud in 20 minutes. Actually, that's a bit disingenuous. The talk is 20 minutes long. It's going to take you a little longer than that. My name's John. I run the Scale Factory, which is a small consultancy. We help organizations of all sorts of sizes, shapes, business sectors design, build, scale, and operate their internet infrastructure. So we've done quite a bit of this cloud migration stuff before, and so I'm hoping to share a few of the things that we've learned in the hope that that is also useful to you. So we're going to cover briefly what things you might want to consider when you're migrating out. We're going to talk about the characteristics of cloud computing, particularly as distinct from either physical infrastructure in your own data center or dedicated servers that you might be buying from our sponsors at Rackspace, for example. We're going to talk briefly about some things that I think you ought to avoid, things that I've seen organizations attempt to do that are, I think, not very clever, and hopefully you'll agree. And we'll also talk then about what I think you ought to do instead, if that's the case. So when you're doing a migration, there are some things that you probably want to consider, things that you care about, things that your business cares about particularly. There's no point just deciding gung-ho tomorrow we're going to take our application out of our data center and take it out to the cloud without really thinking about which of these things are important to you. Cost is obviously fairly important to most businesses to some extent, but maybe isn't as important as some of the rest. But in particular, in the cloud world, we're looking at the difference between capital expenditure and operational expenditure. So what are you buying up front versus what are you operating? Most cloud providers will concentrate mostly on operational expenditure, but the likes of Amazon will let you buy up front certain numbers of reserved instances that reduce your operational expenditure and let you kind of balance those costs out over time. You might be interested in getting out to the cloud specifically for capacity reasons. You might have filled a data center up, and you may be wooed by this idea of near infinite capacity provided by somebody else out in this ephemeral cloud that we've all heard so much about. You might be specifically interested in the elasticity of cloud computing. You might have a workload such as the folks at Just Eat, where every time zone they operate in, it's around dinner time. They get an ass load of connections come in to do people buying their takeaway for the evening and then spin back down again. That might be something that suits your workload, so maybe elasticity is where you want to be looking. You should probably consider what aspects of security you care about. Certainly, most web applications or online services need to consider security to some extent, whether you're in a regulated industry like pharmaceuticals or finance, or you're handling credit card details, might inform a slightly different security posture, and that might restrict your choice of cloud providers or send you in a particular direction in terms of your infrastructure design. You might be particularly bothered about availability. If your application absolutely needs to be online 100% of the time, or at least 5 nines or whatever, then how you architect for that and how you choose your cloud vendor and how you build those systems is going to be informed by that requirement. You might also have geographic dependencies, so you may require specifically that your data live in certain geographies for various compliance and regulatory reasons. You might need your compute to be as close to your users as possible for reasons of latency and performance. You might need to support Asia Pac, for example, in which case you're going to be worrying about, can I get servers in Singapore or Hong Kong to serve those users? That's going to inform which vendor you choose, how you're going to build those systems. One thing you might be particularly interested in getting into the cloud for is that you've heard that you can be particularly agile now. You can change things much more quickly in a physical data center. Certainly, we've worked with some large organizations who've outsourced their physical data center operations, and things like firewall rules involve filling out Word documents and sending them to a team in Bangalore and waiting 24 hours for them to not do it right and then doing it all over again. This isn't a lot of fun. Of course, if you can replace that with API calls, such as you can in the cloud, that's much more interesting and less prone to mistake. You might be particularly interested in getting out to the cloud because of its cool factor, and I feel a bit like a geography teacher saying that because we've had cloud computing for long enough now that probably it's not really considered cool so much as just a thing that's there now. But if you're in a sort of laggard industry where you haven't really looked at this stuff before, then it might be cool for you to start looking at this stuff. So let's think about the characteristics of cloud as compared to physical infrastructure. This quote at the top, I don't recall where it's from. There is no cloud, just other people's computers. And the second quote there, everything fails all the time, which is a quote from Werner Vogels, who's the CTO at Amazon, or Amazon Web Services. When you're operating at the scale of some of these larger cloud vendors, obviously there are failures happening at all times across all data centers, across all regions. The fundamental point here is that you don't own every part of your uptime, or at least you don't own how things are operated. You don't own how the hardware is configured. You don't own certain things about how this stuff runs. And so you need to be considering that in order for you to own the uptime of your own application, particularly if you have concerns around availability, you need to be building your application in such a way that you are dealing with the failure of instances or nodes or data centers and seamlessly recovering from it. One other thing to be concerned about in the cloud is that most public clouds are multi-tenant, which means that more than one customer could be using the same piece of hardware that your stuff is deployed onto. Now, the bigger players have, broadly speaking, protected you from the consequences of this. Less well-established cloud players will still expose you to the consequences of a noisy neighbor, for example. Knowing how to deal with that, knowing the consequences of that are things that you want to be looking at while you're doing this kind of thing. You also have less control over things like naming and addressing. You can't always control the IP address that your system's going to get in the same way that you would if you were building a physical infrastructure in your data center. And so working around that, learning how to discover resources rather than know that they're in a particular place because you've given them a particular address is one of the things that I think is a bit of a mindset shift when you're moving from a physical infrastructure environment out into the cloud world. But in return for that, of course, you get more rapid provisioning of resources, more rapid change. You're able to add more tin in particularly noisy or busy environments pretty quickly. And with relatively little friction. So there's a bit of a trade-off. You don't control as much, but the things that you do control, you can control with a bit more velocity. So things that you shouldn't do when you're thinking of taking your workload out into the cloud. I don't think you ought to be looking at what I'm calling a forklift migration, which is where you take a look at your existing vSphere or VMware infrastructure and you replicate it exactly down to the instance sizes, everything else. Put that in the cloud and call the job done. I also think you ought to avoid the cloud as DR approach, which is where you do the same thing but you leave it all turned off until there's a problem, and then when there is a problem coming up, you are running around trying to get your cloud resources up and running with the latest data. This I don't think is sensible because as we've already discussed, the way that a cloud infrastructure looks is quite different to how a physical infrastructure looks. And if you're just picking up wholesale your VMware infrastructure and moving it like for like into, say, Amazon or somewhere else, I don't think you're going to get the best out of the cloud infrastructure that you're paying for. Other things that are worth avoiding: don't do all this stuff manually. I have worked in organizations where putting together a cloud infrastructure has involved a lot of point and click in the Amazon console, as you would if you were using vSphere. We've moved on from there, and this is a DevOps meetup, so I hope I'm not. I hope I don't have to convince anybody that automation is a good thing, but it is. So if you're doing any of this stuff manually, then you're probably going to have a bad time. Other things that you ought to not do. Don't mistake the scalability of abundant cloud resources for performance. You can get a lot of kit That's quite easy to do, but that isn't necessarily going to improve the performance of your application. You have to look at your architecture, you have to look at how your application is working with those cloud resources. Just throwing more kit at it probably isn't going to work the way you would like. It does work in some circumstances, but there's a lot of performance tuning and other things to do to get to that point. We've said already, everything breaks all the time. Let's not assume that the cloud is a reliable platform. Certainly, the cloud is no less reliable than the stuff in your data center necessarily. But you don't own all of that reliability, and you need to figure out how you're going to work around the unreliability of some of the components. So we're going to do this instead. If forklift and everything else is off the table, we're going to design, build, and operate our own architecture for this stuff. And if there's one thing I want you to take away from today in terms of how you go about this, it's really important to bear this in mind. If you assume that this is if the entire pie chart here is 5 years, which is a reasonable life cycle for an infrastructure within a business application, the amount of time that you spend designing and building that infrastructure is, say, 5%. It's maybe sort of up to 3 months compared to the 95% of time that you're going to spend operating it. And so if the thing that you're building is not designed to be operated, then you're going to have a bad time. And we've worked in organizations where the infrastructure that's being replaced has been designed for being built, but has never been designed to be operated. So the infrastructure design documents that you kind of look at and go, why have they done these crazy things, cover how the network's going to be addressed, where the VLANs are going, what the firewall rules look like, but out of scope in that project were backups, monitoring, log aggregation, all the things that you need to do, patching on a regular basis to actually operate an infrastructure. That wasn't there. So you need to be thinking about operations, not just how do I get the application working in this environment. So we design to operate. And part of that is keeping things simple. There's no point complicating matters. I think as technologists, we have a tendency to go about things in the most complex way possible, partly because it's more interesting, I suppose, but it's really not clever to do that. So try and keep your design simple, minimum number of components, minimum number of moving parts, minimum amount of coupling. Otherwise, operations in future is going to be more difficult, more error-prone, and it's going to keep you awake at night. Security is another thing that needs designing in from day one. If you've ever tried to add higher levels of security to an existing infrastructure, you'll know that it's not as easy as it sounds. From day one, you want to be thinking about, how do I segregate my network? Do I have a DMZ at the front and a private networking behind? Do I require users to get at administrative interfaces via a VPN? Do they authenticate themselves against some kind of shared authentication platform? Do they have a second factor of authentication? Is there a token or a key fob or a YubiKey or something of that nature? Do we restrict outbound traffic from that network completely except via specific proxies with whitelisting? All of that kind of stuff. You want to design that from day one and figure out what your security posture needs to be for the type of app and the type of data that you're dealing with, because adding that later is not going to be possible. You can strengthen an existing security design later on with relative ease comparatively, but you have to start with those foundations. It's also important while you design your infrastructure for your cloud migration to use the strengths of the cloud platform. And I think this is the reason why I don't think a forklift migration or a cloud as DR model really works very well. You're not playing to those strengths. I'm going to use Amazon as an example simply because that's the platform we have the most experience with, and I think it's probably the more advanced in terms of features. But if you look at how what Amazon provides you in terms of resources, you can give to them the operation of all your data services. So rather than running your own MySQL, you can set up an RDS MySQL, and all of that's taken care of for you. That's the strength of the platform. There's no point you building your own MySQL cluster when that's all taken care of by the platform. things like auto-scaling groups, things like IAM, role-based security for access to resources, all of those kind of things that platform provides you. Know what it offers you, use them as best you can in your design, and it'll make your life easier in the long run, particularly give you far less to worry about operationally speaking. On a similar subject, when you're designing these sorts of things, actually when you're designing any infrastructure, whether it's physical or whether it's cloud or what, it's worth considering where your state lives. Now, where does it live? How long do we keep it for? How often does it need to be backed up? If it goes away, how do we replace it? All of those sort of questions around what data makes up your application are all worth looking at as part of the design process. If you can segregate your state into a small number of known locations, then only those small number of known locations need to be backed up or highly available, and everything else can be as disposable as possible. And treating your compute instances as disposable is a really important tool in the sort of design toolbox for a cloud infrastructure. As long as your compute nodes are disposable, they can be disposed of. And if they can be disposed of, then you don't need to worry too much about losing one because something fails. Or you don't need to worry quite so much about how those things scale if you're going to be using the elastic capabilities of the platform, spinning up and throwing away new instances to do compute at busy times. If those instances are disposable, you don't have to worry about cleaning up after them, storing the things that they generated, all that kind of stuff. Consider using load balancing or failover for high availability. There are very few services that you can operate in cloud that there's no way at all of making highly available, whether that's it will recreate itself somewhere after an instance falls over, or there are multiple of them and you can balance traffic between them. Sometimes I guess the benefit outweighs the cost. Sometimes the other way around, but in general, you should be looking at things as being highly available components. That said, saying that using the strength of the platform is a good thing. It's important to try and remain portable to some extent. I think you could assume that Amazon's going to be around forever, and you might well be right, but there may be other reasons why you might want to pick up your application and move it to Google Cloud or whatever else is around the corner next. And so not relying on entirely bespoke custom parts of one particular cloud is a useful strategy. So, for example, Amazon provides you with the simple queue service, which is a queue, message queue. It's possible to wrap that in an abstraction so that you could pick that infrastructure up off of Amazon, deploy it somewhere else, and use a local queue, or you could use Redis queue or some other thing. Consider which of the interfaces that you're using might be proprietary and try and kind of abstract your way away from those to some extent. Once you get into the build phase, having kind of sat down and thought about how all these things fit together, the only real kind of instruction I need to give here is automate it. There are a lot of extremely good tools around, mostly from HashiCorp, to be fair, to build either machine templates with Packer, for example, or to provision the infrastructure themselves using Terraform. I mentioned CloudFormation here because that's what you'd be using if you've been doing this sort of thing in Amazon up until now. Consider looking at Terraform; it's substantially more sensible. Configuring stuff on your infrastructure itself using Puppet, Chef, or one of the newer players. All of these tools allow you to express what you're doing in that cloud platform as code. They allow you to test, to some extent, some of the pieces. They allow you to put them through change management, through continuous deployment. And as soon as you've automated all of this stuff, it becomes really straightforward to pick up an infrastructure design and redeploy it in another region, in another VPC, so that you can do performance testing in a like-for-like environment or other types of testing. you can't do that if you haven't automated it. So look at the automation stuff. And then you're going to deploy software onto the platform, and how you do that will probably depend on what kind of application you're using. In the current world, you might be looking at using Docker and other container technologies for doing that kind of thing. You're going to hear, I guess, about that in the next 2 talks. But ultimately, the thing to take away from this is automate it. From there, once you've built the thing, you're going to be operating it. And this is why I say it's important to design to operate. You're going to be doing this sort of thing for 95% of the lifetime of the infrastructure, or possibly more. So you need to think about how you're going to orchestrate the types of incremental change that might happen over time on an operational infrastructure, such as patching for security. The type of orchestration that I'm thinking about here would allow you to patch against the likes of Heartbleed in minutes. Things like M-Collective from Puppet Labs allow you to do this sort of thing centrally and in parallel across a whole fleet of machines. As well as orchestration for ongoing change, you're going to want to be monitoring everything. You could use data loop, as we've heard. There are other options available. And the things that you're going to want to look at are, how available is my service? Can I know that my service is up? And if it's down, can I know that before my customer or my boss? You're going to want to look at resource usage for capacity planning. Do I need more machines? Do I need to automatically scale up and add some more kit? Am I running out of disk space? Is my database performing well? You want to monitor performance metrics. How long does it take my infrastructure to deliver the page or the API response that's being requested? How does that change over time? How does that change given other prevailing information about what's going on in the infrastructure? As my page load or request load increases, how is my performance affected? How does that influenced by the resource usage? How do those things play together? All of that stuff is really useful to know. Adding business metrics to the same dashboard is also a really useful thing to do. If nothing else, it allows you to see the financial impact of an outage, or it allows you to demonstrate when you need to spend some more money on stuff, why you need to spend some more money on stuff. As well as sort of ongoing numerical data points over time, you're also going to want to pull all your logs together in one place. Once you have an infrastructure that spans tens of instances, it gets very tiresome to have to log into individual machines, to look through logs to figure out what was going on. When it gets to hundreds of machines, you absolutely aren't going to be doing that. So aggregating logs through something like Logstash or Splunk or one of the SaaS solutions for this stuff is an invaluable tool in debugging, in knowing what's going on. It's great for finding anomalous behaviors. We have a customer who found a backdoor in their app this week as a result of seeing things in their logs that they didn't recognize just by spelunking around in this stuff. And given all of these pieces of information, you can then continuously improve how you operate that infrastructure. Without this sort of data, there's no way that you know what to improve. There's no way that you know how best to spend your time. Continuous improvement really is the way forward. I don't think I have time to take you through this in loads of detail. This is a platform that we call ReadyScale, which is our sort of foundational cloud infrastructure that we can deploy in a short space of time using the type of techniques that I've just described and taking some of those things into account. We build customer applications on top of that. If you'd like to know anything more about that, come and find me. I'll be having a beer and pizza with you all at the top of the hour. And you can find me here.
Thank you, John.
Thank you.
So while John and Craig swap the mic, any question for John? Right, I'll go there. And of course, everyone is asking, where is the pizza? It will be here at the end. So you have to stay.
Quick question about what's your approach on DR and backups for cloud?
If you're using something like, the question was, what's your approach on DR and backups? If you're using cloud-provided storage as part of, say, RDS in Amazon or an Elastic Block Store or whatever, then generally speaking, we use whatever those tools provide for backups. So RDS can be snapshotted periodically. You can restore point in time from any one of those snapshots. EBS is we can tag with tags that indicate how frequently and how much retention to add, and then there's a periodic job that will do those sort of snapshots. Where you get into more sort of application level backups, for example, if you're running an LDAP service or something of that nature where you want to actually extract the structured data from the service beforehand, we tend to use something like Bacula, which is an open source tool for orchestrating that kind of thing. Going back to the DR question, it sort of depends on the application. If you're looking at a regular kind of transactional web application, then intentionally building into 2 availability zones within Amazon gives you a level of availability for not necessarily free, but for minimum effort compared to running it in a single availability zone. Then that's broadly sufficient for most availability requirements. You get sort of 4 nines out of that. If you have more extensive DR requirements, then running out of multiple regions and doing DNS failover and that sort of thing is an option. And then you're into the sort of world where how are you managing state between those regions, and that becomes an application build problem. So the infrastructure isn't going to get you out of the DR plan completely, but by working with the application developers, you can understand the availability constraints of what you're building, such that you can do a good job for whatever workload you're doing.
Thank you again.
Yep.